Hey everyone, and welcome back for another deep dive. You know how much we all love to tinker and explore new ideas, right? Well, today we're taking a trip back in time to 2012 to explore a workshop that took place in Singapore. It's all about something called open source physics.
And trust me, this is way cooler than it might sound at first glance.
Oh, I bet. So before we get lost in the equations and theories, could you give us a quick overview of what exactly open source physics is? I mean, it sounds pretty self-explanatory, but
Sure thing. At its core, open source physics, or OSP as it's often called, is all about making physics education more hands-on, interactive, and accessible. Imagine a world where anyone, regardless of their background or resources, can access and even modify sophisticated physics simulations.
wow. It's a pretty powerful concept. So it's like taking those complex formulas and abstract theories from textbooks and turning them into something you can actually see and interact with.
Precisely. Instead of just reading about a pendulum swinging, you can actually build a virtual pendulum, tweak its parameters, and see how it behaves in real time.
Yeah.
It's all about learning by doing and experiencing physics firsthand.
That makes so much sense. So how does this open source aspect come into play? I mean, are we talking about some sort of secret society of physics enthusiasts sharing their secret knowledge?
Not quite a secret society, but definitely a passionate community. The idea behind open source is that the source code of these simulations is freely available under licenses like the GNU General Public License. This means that anyone can use, modify, and even redistribute these simulations without any restrictions.
So it's like a giant collaborative playground where everyone can contribute their ideas and creations and build upon each other's work.
Exactly. It's about fostering a culture of sharing, collaboration, and continuous improvement. And that brings us to this fascinating workshop held at the National Institute of Education in Singapore back in 2012.
Okay, so we've got the open source concept down. Now tell me more about this workshop. What was the main focus?
The workshop was all about introducing participants to a powerful tool called Easy Java Simulations, or EJS. It's a free authoring environment that allows anyone, even those without extensive programming experience, to create and modify physics simulations.
EJS. Now that rings a bell. I vaguely remember something about Java from my computer science class back in the day.
Don't worry, EJS is designed to be much more intuitive than those old-school programming languages.
Yeah.
It's all about visual programming. Think, drag and drop, connect the dots, and voila, you've got a working simulation.
Sounds a lot less intimidating than I remember coding being. So did people actually get to build their own simulations at this workshop?
Oh, absolutely. The organizers pack a ton of hands-on activities into a surprisingly short amount of time.
Wait, really? How short are we talking about here?
Believe it or not, the entire workshop was condensed to just 90 minutes.
Wow, 90 minutes. That's barely enough time to grab a coffee and catch up on emails, let
Yeah.
alone learn how to create physics simulations.
I know, right? But the organizers were incredibly efficient. They managed to squeeze in a crash course on OSP and EJS, and then they let the participants loose to experiment and explore on their own.
So what sorts of things did people actually create in those 90 minutes? Did they manage to build anything impressive, or was it more about getting a taste of what's possible with EJS?
It was a mix of both. While building super complex simulations from scratch in 90 minutes might be a bit of a stretch, participants definitely got their hands dirty. They worked with existing simulations from the OSP digital libraries, tweaked them, modified them, and basically made them their own.
So kind of like taking a pre-built model car and then swapping out the engine, adding some custom paint, and making it your own unique creation.
That's a great analogy. It's all about taking something that already works and then experimenting with it, seeing how different parameters affect the outcome, exploring the possibilities.
I love that. So what were some of the specific simulations they played around with? Anything particularly memorable or mind-blowing?
One of the key examples they focused on was a spring mass system. Now, before you roll your eyes and think back to those dreaded physics textbooks, just imagine a simple spring attached to a weight.
Okay, I can picture that. We've all played with a slinky at some point, right?
Exactly. Now, if you pull that weight down and let go, it starts bouncing up and down. That's a spring mass system in action, and it's a fundamental concept in physics.
Okay, that makes sense. So how do they use UJS to explore this spring mass system? Do they just watch a pre-recorded animation, or?
Oh no, they actually got to interact with it. They could change different parameters like the stiffness of the spring or the mass of the weight, and then immediately see how those changes affected the system's behavior.
So they could literally play around with the virtual spring,
Yeah.
pull it, stretch it, add more weight, and see how it responded in real time.
Exactly. It's a fantastic way to visualize abstract concepts and really understand how different factors interact. And it wasn't just about individual exploration either. Participants worked in groups, brainstormed ideas, and helped each other troubleshoot problems.
Ah, so they turned physics into a team sport.
I love that collaborative aspect. It must have been really inspiring to see people from different backgrounds coming together to learn and create something new. But where did they share their creations? Did they just keep them on their own computers, or was there a way to showcase their work to a wider audience?
That's where things get even more interesting. They had access to a platform called the NTNU Java Virtual Lab, which is essentially an online space where anyone can share and access EJS simulations, like a giant digital library dedicated to physics simulations. And it's not just about showcasing completed work either. People can download, modify, and build upon each other's creations, fostering that spirit of open source collaboration.
Wow, that's incredible. So even after the workshop ended, their work could live on and inspire others to learn and explore. And what about the organizers themselves? Did they just pack up their bags and call it a day after those 90 minutes, or did they continue to share their knowledge and resources with the world? Oh, they definitely didn't stop there. They went above and beyond to make their work accessible. They created lesson packages based on the workshop activities and shared them on an educational portal called the ICT Connection EduMall 2.0.
So they essentially bottled up the essence of their workshop and made it available for anyone to access and benefit from.
That's amazing.
Yeah.
But before we delve deeper into those platforms, could you give us a bit more context on what exactly the NTNU Java Virtual Lab and the ICT Connection EduMall 2.0 are all about?
Of course. The NTNU Java Virtual Lab, hosted by the Nanyang Technological University in Singapore, is a web-based platform that lets you run EJS simulations without needing to install anything on your computer. Think of it like a streaming service, but for physics
Okay,
simulations.
I'm already loving the sound of this. What about the ICT Connection EduMall 2.0?
The Edumall is an online platform developed by Singapore's Ministry of Education. It's a hub for all sorts of digital educational resources, including lesson plans, multimedia content, and even assessment tools. It's like a one-stop shop for teachers and students looking for engaging and innovative learning materials. Wow, they really thought of everything. It sounds like this 90-minute workshop had a much larger ripple effect than anyone could have imagined. It's like they planted the seeds for a new way of teaching and learning physics.
Precisely. And this brings us to one of the most fascinating aspects of open source physics, its ability to transcend geographical boundaries and connect people from all over the world who share a passion for physics and education. But before we dive into the global impact of OSP, I want to circle back to EJS for a moment. You mentioned earlier that it's incredibly user-friendly, but what exactly makes it so special compared to other programming tools? What are some of the key features that make it so intuitive and easy to use?
Yeah, I'm curious about that too, because while I love the idea of creating my own physics simulations, I'm not exactly a coding whiz.
Hmm.
So what is it about EJS that makes it so accessible, even for someone like me?
One of the key features that sets EJS apart is its visual approach to building simulations. You don't need to be a coding expert to create something amazing. It's like building with virtual Lego blocks.
Okay, now you're speaking my language. Lego blocks I can definitely handle. So walk me through this a bit. What are some of the specific tools and features within EJS that make it so intuitive?
Okay, I see what you mean. It's like you're creating a virtual world where you can control the laws of physics.
That's a great way to put it. And EJS provides you with all sorts of tools to make this world come alive.
Hmm.
You can customize the appearance of your simulations, adding colors, textures, and even 3D models to make them more visually appealing and engaging.
So it's not just about the numbers and equations, it's about creating a visual experience that makes physics come alive.
Exactly. And that visual aspect is incredibly important for learning. When you can see how things work, it's much easier to grasp the underlying concepts.
This makes me think about all the potential applications of OSP beyond just traditional physics education. I mean, you mentioned earlier that it has applications in other fields too. Could you elaborate on that a bit? Absolutely. The principles and tools of OSP extend far beyond the classroom. Think about engineering, for example. Engineers use simulations all the time to design and test everything, from bridges and buildings to airplanes and smartphones.
So instead of building expensive physical prototypes, they can test out their designs virtually using OSP simulations.
Precisely. And it's not just about design. They can also use simulations to optimize performance, troubleshoot problems, and even predict how a system will behave under different conditions.
That's incredible. It's like having a virtual laboratory where you can experiment without any real-world consequences.
Exactly. And it's not just limited to engineering. Researchers in fields like astrophysics, climate science, and even medicine are using OSP to model complex phenomena, analyze data, and test hypotheses.
So OSP is helping us unlock the secrets of the universe, from the tiniest atoms to the largest galaxies.
It is. And let's not forget the everyday problem solver. You don't need to be a scientist or an engineer to benefit from OSP. Let's say you're trying to figure out the best angle to launch a projectile or the optimal way to arrange furniture in your living room.
You're telling me I could use OSP to become a master furniture arranger? Sign me up.
Well, maybe not a master, but it could definitely help you visualize different layouts and experiment with various arrangements before you start moving heavy furniture around.
Okay, I see your point. It's all about using simulations to explore different possibilities without real-world consequences.
Exactly. OSP empowers you to become an active learner, to ask questions, test ideas, and discover solutions on your own.
This has been such an eye-opening conversation. I feel like I've only scratched the surface of what OSP has to offer. But I'm curious about something. You've talked about the amazing potential of OSP, but what about the challenges? Were there any obstacles or difficulties that participants faced during the workshop?
That's a great question. Even with a user-friendly tool like EJS, there's always a learning curve. Some participants struggled with understanding the underlying physics concepts, while others had technical difficulties getting EJS set up on their computers.
So even in this supportive and collaborative environment, there were still moments of frustration.
Of course. Learning something new, especially in the realm of technology, always comes with its share of bumps in the road. But what's important is how these challenges were addressed.
So how did they overcome these hurdles? Did they just muddle through on their own, or was there a support system in place?
The workshop organizers and facilitators played a crucial role in providing guidance and support. They offered one-on-one assistance, answered questions, and helped participants troubleshoot any technical issues they encountered.
It sounds like they created a really positive and supportive learning environment where everyone felt comfortable asking for help.
Exactly. And that's one of the hallmarks of the open source community in general. There's a strong emphasis on collaboration and helping each other out.
That's wonderful. So even though there were challenges, participants never felt like they were alone in their struggles.
Precisely. And this sense of community extended beyond the workshop itself. The organizers made sure that participants had access to online forums, discussion groups, and other resources where they could continue learning and connecting with others.
So the learning didn't stop when the workshop ended. It was just the beginning of a much larger journey.
Absolutely. And that's a key takeaway from this deep dive. Open source physics isn't just about tools and simulations. It's about fostering a culture of learning, collaboration, and shared discovery.
This has been such an eye-opening conversation. I feel like I'm starting to see physics in a whole new light. It's not just about memorizing formulas anymore. It's about exploration, experimentation, and collaboration. But I'm curious to know more about the impact of this workshop beyond the immediate participants. Did the organizers track how these newly acquired skills and resources were actually being used in classrooms or other settings?
While specific long-term impacts may not be fully captured in our source material, it's clear the organizers were committed to spreading their work. They disseminated it through the NTNU Java Virtual Lab and ICT Connection EduMall 2.0, ensuring the workshop's knowledge and resources reached a much broader audience.
So they were planting the seeds for a broader transformation in physics education.
Exactly. Their efforts even earned them a gold award from Singapore's Ministry of Education for their innovative approach to teaching.
Wow, a gold award. That's impressive. It really shows that their work was groundbreaking and had a real impact.
It highlights how important it is to support educators who are pushing the boundaries of traditional teaching methods. These individuals inspire students and contribute to a more informed and engaged society.
It reminds us that even something as seemingly small as a 90-minute workshop can have a lasting impact.
Absolutely. It speaks to the power of open source principles, collaboration accessibility, and the belief that knowledge is meant to be shared.
So what's the key takeaway for our listeners who might be feeling overwhelmed by all this information?
The key takeaway is that open source physics is for everyone. You don't need to be a physics expert or a coding whiz to benefit from it. It's about curiosity, experimentation, and continuous learning.
It's about empowering yourself to explore the world around you, ask questions, and seek answers using the amazing tools at your fingertips.
Exactly. And you don't have to do it alone. The open source community is filled with passionate individuals eager to share their knowledge and support each other.
It's like a global network of explorers united by their love of physics and the pursuit of knowledge. But before we wrap up, I'm curious to know what our listeners can do if they're feeling inspired to dive into this world of open source physics. What are some concrete steps they can take to get started?
First step, explore. Remember the EJS download link. It's a great place to start. Download it, experiment, and see what you can create. Also, check out the open source physics digital libraries for pre-made simulations you can customize.
And don't be afraid to reach out to the OSP community. There are forums, groups, even conferences to connect, share ideas, and get support.
Exactly. The community is incredibly welcoming, so don't hesitate to ask questions, share your projects, and collaborate.
So it's about taking that first step, embracing exploration, and connecting with a community of like-minded people.
Precisely. Who knows where that first step might lead? The possibilities are truly endless.
It's amazing to think that something as complex as physics can be so accessible and engaging through open source tools and this community. It really does feel like a whole new world is out there waiting to be explored.
And the best part is that it's constantly growing and changing. With each new contribution, each new simulation and connection, the potential for discovery grows exponentially.
You know what? You've made me wish I had access to these resources back when I was in school. Maybe I would actually enjoyed physics class.
It's never too late to rediscover the joy of learning. And that's another amazing thing about open source physics. It breaks down the barriers that often make complex subjects intimidating, encouraging play experimentation and learning at your own pace.
It feels like a whole new approach to learning, making it more collaborative, personalized, and meaningful.
Absolutely. It's not just about technical skills or knowledge. It's about cultivating curiosity, embracing challenges, and believing in shared knowledge.
So as we wrap up our deep dive, what's the one message you want our listeners to take away? What's the spark to ignite their own OSP journey?
Don't be afraid to jump in. The resources are out there. Whether you're a student, educator, researcher, or just curious, there's a place for you in this community. Download EJS, check out the digital libraries, connect with others. Who knows what you'll discover?
And remember, it's not about being an expert or having all the answers. It's about the journey, learning from mistakes and pushing boundaries together.
That's the beauty of open source. It's a collective effort. Every contribution, no matter how small, adds to its richness and makes it more powerful for everyone.
So to our listeners, take that first step. Embrace the spirit of open source physics and unlock those endless possibilities. Who knows? Maybe someday we'll feature your creation on a future Deep Dive.
Until then, keep exploring, keep learning, and keep sharing your passion with the world.
That's a wrap on our deep dive into open source physics. We hope you enjoyed it as much as we did. Until next time, stay curious. You're so right. It's like this whole movement is redefining what it means to learn and explore, especially when it comes to something as complex as physics.
It is. And it's not just about physics either. These principles of open source collaboration and accessibility can be applied to so many different fields.
I can already see the wheels turning in our listeners' minds.
Yeah.
They're probably thinking, okay, this all sounds amazing, but where do I even begin?
Well, the beauty of it is that you can start anywhere. Remember that EJS download link we mentioned earlier? That's a fantastic place to jump in. Download it, play around with it, see what you can create. There's no pressure, no right or wrong answers, just pure exploration and discovery.
And if you hit a roadblock or have a question, don't hesitate to reach out to the OSP community.
Exactly. There are forums, discussion groups, online resources galore. You'll find a welcoming and supportive network of people who are passionate about sharing their knowledge and helping others learn.
It's like having a global team of mentors and collaborators right at your fingertips.
Precisely. And who knows, maybe someday we'll be featuring your groundbreaking simulation or educational resource on a future episode of The Deep Dive.
Now that's an invitation I bet our listeners can't resist. So as we wrap up this incredible journey into the world of open source physics, what's the one message you want to leave our audience with?
Simple. Embrace curiosity. Never stop exploring, and remember that knowledge is meant to be shared.
Beautifully said. And on that note, we'd like to thank you, our amazing listeners, for joining us on this deep dive into the fascinating world of open source physics. We hope you've learned something new, discovered a passion you never knew you had, and maybe even felt inspired to create something amazing.
Until next time, keep those minds curious, those hearts open, and never stop exploring the wonders of the universe.
From all of us here at The Deep Dive, we'll see you on our next adventure.